Hello everyone, I am Dr.D.Revathi working as an assistant professor in Department of Data Analytics at Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. Today we are going to catch a new topic called as a error detection technique. This is how the error detection has been carried out um, in three ways. That is a single parity check, CRC, that is cyclic redundancy check, and the checksum. In the previous video, we have seen the CRC, but we have used the XOR method. But here we are going to use the binary division method so that it uses multiple things to check. Here you can able to see the cyclic redundancy check flow chart. That is n bits of data, n bit with the data has been divided using the binary division method, and it produces the reminder. The reminder is thing. Reminder is captured as CRC, that is n bits, and then with the reminder and the bit can be transferred to the receiver, and the receiver receives the CRC with the data, and it divides, and it uses the same divisor, and if the reminder is 0 in the sense it accept, if the reminder is 1 in the sense it will reject. That is called as a technique which has been used by the CRC here. Here we can see in detail, that is we are transferring k bit of frame or message in the sense it has been generated n bit of sequence, that is called as a frame check sequence, and resulting frame is k plus n bits is exactly divisible by the same predetermined number. That is the receiver then divides the incoming frame with the same number. If there is no reminder, it assumes there is no error there. We are dividing using the binary division method. The binary division method is calculated by using the binary subtraction, as we already know how the binary division has been carried out. Here we are going to see an example, that is 100100000 has been divided with the 1101. The first in the this is called as a divisor, and it has been divided using first time, that is 1 1101 is we are dividing with 1101. 1 minus 1 is 0, 0 minus 0 is 0, and here this is 0 minus 1, we can't be able to divide, so we are borrowing 1 from the next digit and it becomes 10. 10 minus 1 is 1. We are now having only 3 numbers. We are extracting another number, that is 0 here, and we are dividing with the 1 here. That is we are dividing the thing with the 1, and the second time it becomes 1101, and 1101, that is here in the same way 0 minus 1 is not divided, and it has been borrowed from the next bit, that is 10 minus 1 is 1, and here it becomes 0 minus 0 is 0, and here also 10 minus 1 is 1, and just here we don't have any value, in the sense 1 minus 1 is 0. That's why we are neglecting the value here, and we are just taking another 0 from the above thing. It becomes 1010, and it has been divided with the same number, that is 1101. In the same way 10 minus 1 is 1, and 1 minus 0, that is 1, and here also 10 minus 1 is 1, and we are just borrowing the next we are just dragging the another 0 here, and it has been divided with the same 1, that is 1101, and 10 minus 1 is 1, and 1 minus 0 is 0, and in the same way 1 minus 1 is 0, and here also 1 minus 1 is 0, and we are extracting the another element, that is 0 here, and it has been divided with the 0 times, and it becomes 1100, and it has been divided with the 1101. Now the remainder becomes 001. Here we are accepting the CRC value as 001. In the simple parity check code, we are just using the parity bit as the code word. That is, the message is 000 and parity is 0. We are adding the parity bit extra. In the same way here, 001, and the parity bit is adding with the code. That is code word. In the checksum, we are just having n bits of data, and which has been summed, and it has been complemented and transferred to the receiver, and it extracts the k sections, and it checks sum with the n bits. If the sum is all 1, in the sense it accept, or otherwise it will reject. At the center side, the unit is divided into k section of n bits. All the sections are added using 1's complement to get the sum. The sum is complemented, it becomes the checksum. The checksum is sent with the data. At the receiver end, the unit is divided into k section of n bits. All the sections are added together and using 1's complement to get the sum. If the sum is complemented, the result is 0. The data are accepted, otherwise they are rejected. Thank you. We'll catch you in the next video. Thank you all.